All right, so now we're going to talk about the monopolist problem and basically how monopolists behave if we assume that they're going to be profit maximizers, which again is a stylistic assumption. Might not always be the case, but largely this is like a good starting point at the very least for most economic models that involve monopolies. So any industry with a monopoly, maybe the individual firm isn't going to be solely based on profit maximization. Maybe they're based on limiting the number of entrants, or maybe they're colluding with the government, or maybe they're genuinely interested in branding or social welfare or something like that. But overall, it's probably the most rational starting point, the most logical starting point. And if you want to tweak your model from there, you can, but this is probably where you should start. Okay. So like any other producer, the monopolists in Econ 1, if they're rational, they should seek to maximize their profit, total revenue minus total cost. Unlike in perfect competition, price is no longer a given for the firm. So the firm's supply is the market's supply, and producers can influence the price directly or by shifting output. Okay, so you can either you can basically change. You can either set the price and let that change your output, or you can change your quantity and let that determine what your what the market price is. Okay, so you have control over which variable you want to set as a monopolist, and that'll determine the quantity supplied and demanded, like the equilibrium quantity and the equilibrium price. Okay. So this is a real thing. Suppose that the Wu-Tang Clan had the ability to create an original vinyl pressing that are impossible to pirate. So this is going back to that guy, Martin Shkreli. He was the guy who ended up buying this. But the Wu-Tang Clan is a rap group. They produced one copy of a particular CD that was impossible to pirate. So in this case, they can produce more copies because I have 6. So they face the demand P equals negative 50, quantity demanded plus 600. Their fixed cost is 100, and their variable costs are as given. So this is their variable cost over here. Okay. So I have a little bit of a Excel sheet here with those 3 variables. Okay, so basically the Wu-Tang Clan can decide how many albums they want to create. Do they want to create 0.5 albums? Do they want to create 6 albums? They can determine the number of pressings. So in the real world, they only created 1, but they have profit maximizing ability, so they know that their demand curve, that they've done their market research or whatever, and they know. They know they can figure out how many is the optimum amount to sell. Okay. So we have the demand curve is given. Our fixed cost is 100 across the board. Okay. I shouldn't have left up total cost, but this is the JK is not there anymore. So we want to fill in the rest of this chart here. Okay. So instead of doing 0, I started with 0.5. The reason being, is that the average is, when you divide by 0, is going to be in undefined, right? You can't dividing by 0. Watch. There's an error, not just in Excel, but in all math. It goes to infinity. Okay, so let's first find the price based on the demand curve. So we have a demand curve, negative 50 QD plus 600, and then that was given. So I'm just going to plug in a formula. negative 50. Sorry, my cat's doing crazy things. Negative 50 times the quantity demanded. And then I'm going to add back in 600. Oh, in all that excitement, I must have had a typo. Negative 50 times. Oh, yeah. So the first one should be 550. Yeah. Okay, perfect. So all I did was just calculated the price for each unit. So the second unit would be 2 times 50. So that should be negative 50, right? 2 times negative 50. I don't like how it breaks it out like that. 2 times negative 50 plus 600. So 2 times negative 50 is 100. Negative 100 plus 600 should be 500. Fixed cost was a given at 100. Variable costs were given. That was part of this is the variable cost function of the firm. We have to just assume that the Wu-Tang Clan went up to their suppliers, like their supply chain, and they're like, if I wanted to press one album, how much would that cost me? And the supply chain said 125. If I wanted to press 2 albums, how much would that cost me? 215. Okay, so that's just that's a given. Okay, that's something that you just have to assume essentially. Okay, the rest we can calculate, except for I have this little marginal revenue function, which is like a technical definition of marginal revenue, and I just do that for the graph purpose. That's not the marginal revenue that you'll see in your textbook or that I use in my slides, but it is like the technical definition of marginal revenue that involves calculus. So I can't teach it, but for graph, when I show you the graph, it'll be cleaner, and otherwise it'll be inaccurate. This is the accurate marginal revenue. Okay, and I'm not going to explain it any further. Okay, so total revenue is your price times your quantity. So I'm just going to take my price, which we just calculated, times my quantity, which is this, column 1, and that's our revenue. Total cost is equal to your fixed cost plus your variable cost, and variable cost is a function of Q. So I'm just going to add these two bad boys up. I went too far. You went too far. All right, marginal revenue is your change in revenue. So this one, the first one's going to be minus 0 because we're not making any revenue at 0. Divided by your change in quantity. So this minus 0. And then this one. And now I'm just replacing out 0 with the revenue and the quantity for 0.5. So basically, my marginal revenue should be this minus this divided by 1/2. My marginal revenue for going from 1 to 2 should be this minus this divided by 1, so it should be 450. Okay. Marginal revenue for going from 2 to 3, so that's a unit change of 1, so it should be 1350 minus 1000, that divided by 3 minus 2, so it should be 350, etc., etc. Okay. I'm just taking the change in revenue divided by the change in quantity. I could do the same thing for marginal cost. So this will be the change in revenue, change in cost minus 0. And then we got to divide that by 0.5. So we're going to divide this whole thing by C2 minus 0. And this one, we're going to replace the zeros with the quantity demanded over here and the cost over here. Okay. So my cost going from 5 to 6 should be 200, which it looks like 1160 minus 960 divided by 6 minus 5 should be 200. Okay. So pi is going to be total revenue minus total cost. This is your profit. So I'm just going to take this. I'm going to take this. And I went too far again. Okay. So if I sell 0.5 units, my profit is going to be 62.5. If I sell 6 units, it's going to be 640. Okay. And then my average variable cost is going to be my variable cost divided by Q. Then my average total cost is going to be my average variable cost plus my average fixed cost. But I didn't do average fixed cost. I can just divide column 4 by column 2 here, but instead I'm going to do average total cost is total cost divided by quantity because it's much easier. Okay. All right, so that's essentially a review of just your normal producer theory stuff. Like nothing here is new, except I guess that we built in a demand curve, because in this case the producer is the industry. But everything here is, very straightforward. I guess this is new too, but I told you to ignore it, so you can ignore it. Okay, so this is essentially your like production cost, revenue, and all that kind of stuff, right? And just looking at this, like what's the optimal quantity? Well, you want the optimal quantity when MR equals MC, right? That as long as MR is greater than MC, you should continue producing. That'll increase your profit. Once MR is less than MC, then your profit should start decreasing. So is that the case here? So MR is greater than MC, profit goes up from 0. MR is greater than MC, profit goes up. MR is greater than MC, profit goes up. MR is greater than MC, profit goes up. MR greater than MC, profit goes up. MR less than MC, profit goes down. Your marginal profit is negative 40, right? So this, when MR equals MC, looks like the optimal quantity, assuming that you can't do like 4.5 or something like that. Okay, which I guess is not a consistent assumption because I did do 0.5 here, but let's say they can build half an album, but they can't build 4.5 albums. Okay. Okay. All right, so this is the profit maximizing quantity for, right? You see at the profit maximizing quantity, marginal revenue equals, well, in this case, it's not equal to marginal cost, but it's the point at which marginal revenue is closest to marginal cost without being under it. I feel like I wanted to say another thing, but I guess not. Okay. So yeah, let me show you what these equations look like graphed. So because it's an involved graph, I'd already manipulated it. Okay. In fact, I have it on the slide, and it's a little bit neater because I have it laid out. All right, so this is what we just solved for. Okay. So I have like each curve labeled. Okay, so quantities on the x-axis, and the y-axis will be cost or revenue. Okay. So if we look at marginal revenue, right? This is the technical definition of marginal revenue, by the way, not the one that your book gives, which is a little bit off. This is your demand. Okay. This is your marginal cost. average variable cost, average total cost. So like always, as quantity increases, your fixed cost will go, your average fixed cost goes to zero. So your average total cost and average variable cost start to converge into each other. And your marginal cost, where it crosses average total cost and average variable cost, is the minimum for those values. So it looks like average variable cost will be minimized. Average variable cost will be minimized somewhere between 3 and 4. Average total cost will be minimized somewhere between 4 and 5. And we can actually see that with the, we can actually see that with the graph here. So if we look at average variable cost, it looks like it's minimized closest to 3. Average total cost is minimized closest to 5. So somewhere in between 3 and 4, and somewhere between 4 and 5, like I've said. The demand curve lies above the marginal revenue curve. This is regardless of whether it's the technical definition or not. So 575 versus 550, 550 versus 500, 500 versus 400, 450 versus 300. Okay. Yeah. There's like a calculus way to get that marginal revenue function. Don't worry about it. But your optimal quantity will be when marginal revenue cost is marginal cost. Okay, so somewhere around here. Okay, so at the optimal quantity, so this is your, which one's marginal revenue? Marginal revenue is the green one. Okay, so it should be like over here. Technically speaking, it's at 4, just because there's no discrete thing, but for the sake of labeling, I'm going to keep it there. So you want to charge, or essentially your cost of charging is going to be your average total cost here. Sorry. I have this on? No, I don't have it on whiteboard. What did I just do there? It's a little bit tough. All right, so let me take my pen. Actually, let's keep it at 4. So just know that even though marginal revenue doesn't technically cross marginal cost at 4, I'm going to do it at 4 even still because it's as close as those two get. So this is your average total cost here. And what did I say average total cost was at 4? So it's 192.5. Just going to write 193. We're just going to round for a second. Let's do it. 192. Oh, I was right the first time. 192.5. Okay. So this yellow area that I'm highlighting is ATC, your average total cost, times Q, aka it's your total cost, right, in yellow. what price are you going to set? Are you going to set your price equal to your marginal revenue up here, which is close to your average total cost, but it doesn't have to be. Like if your quantity ended up being here, it would have been different. But they just happen to be grouped together pretty closely, so that makes it harder on you guys. I'm sorry about that. But no, your average total cost does not have to equal your marginal revenue at the optimal quantity. So do you charge at your average total cost and make a zero profit, like normal profit? Do you charge at your marginal revenue? Do you charge at demand? Do you charge at average variable cost for some reason? Your shutdown price? Well, I wouldn't do that. So I definitely want to charge at my shutdown price, because that means that you're incurring a loss of your negative fixed cost, right? I would not charge at your average total cost, because that's your break-even price. Okay, that doesn't make a whole lot of sense. Why would you want zero profit when you can make positive profit? I wouldn't charge at your marginal revenue. Just, I don't know, it just doesn't make a whole lot of sense, because you can charge at your demand, right? This is the price, essentially, that the firm, this is the price that the market is, geez Louise, the market's cool with, right? This is the price that the market demands, essentially the willingness to pay for the fourth good is 400. So you want to charge at 400, right? Okay, so by charging at 400, you are maximizing your profit. How do I know that? Because we just saw it. Okay, so we saw it here, right? This is the top profit. Okay, any other price quantity combination will be lower profit. You can charge your marginal revenue if you're so inclined, with your marginal revenue at that point, 200. Okay, so 200 times 4 is 800. That's your total revenue then, if that's the price that you choose to charge at. So if your total revenue is 800 and your total cost is 770, you've made profit of 30 versus 830. So you can charge double the price if you charge at the price people are willing to pay at. What else? You can tell that the total cost is 192.5 times your quantity, 4. So if you did the math, you should get back 770, which I just did in my head, and it checks out. So that's how you know that this is accurate. But let me highlight the profit here. Highlighter, and I want the highlighter to green for profit. All right, so let's do my pen again. All right, so profit is equal to total revenue, or let's do, price times quantity. In fact, nope. Oh, really? It just did that to me? That's annoying. That's annoying as hell. Alright, so we're going to have this janky highlight right here. Profit is equal to price minus your A, T, C times your quantity. Right? So, remember, price times quantity is your revenue. So profit equals revenue minus cost, total revenue minus total cost. price times quantity is your total revenue. Average total cost times quantity is your total cost. So your profit is price minus average total cost times quantity. Okay, so this whole yellow plus green John, so let's say A, let's say this is B, A plus B is your total revenue, and that's equal to your price times your quantity. Okay. So, what does that say about the monopolist? The monopolist makes a profit because they have control over the uh, the quantity and price at which they set at, which they sell at. They could increase the quantity and charge over here. They'd be decreasing their profit, though. We just saw that, right? So these are their profits, and the more you produce after 4, the lower your profits go. Okay, so it makes sense to restrict your profit to just charge at a higher price. There is like one thing in monopoly, or in general, that firms can do, and that's called price discrimination. Where, let's say you have your demand curve, they might say everybody above here, if we have a way to identify, like everybody on this portion gets one price, everybody on this portion gets a different price. The way you can do that is with like coupons or deals like targeted to certain people, or I know like airlines will sometimes charge people like buyers who buy right before their, like in the week before their flight, a higher price. Reason isn't because of scarcity or something like that. The reason is they know that people who buy flights um, within like a week of their takeoff day are usually like business travelers. Business travelers are more price inelastic than regular old leisure travelers who might wait for a deal. Okay, so that's an option in the monopolist toolbar, but not something that I'm really going to spend a whole lot of time talking about. Besides just that, one other point, and I have this on a later slide. So let's just trace your marginal cost curve, which I kind of lost a little bit, but I'm pretty sure it's this blue one here. Marginal costs should start at 450, then it goes down to 90. So I'm pretty sure it's this guy. Oh no, I'm sorry. It's this one down here. So this is your marginal cost curve. Okay. And presumably it'll intersect demand like somewhere over here. Okay. So in perfect competition, your marginal cost and your demand curve will intersect at the equilibrium price. That is not the case here. Okay, the socially optimal, or like the socially efficient production, would be this quantity right here, where marginal cost is equal to demand. That's allocative efficiency. It's cheaper for the producer to produce than the willingness to pay for that consumer. So as long as as long as there's consumers who are willing to pay at a price higher than the marginal cost of producing that unit, then there's surplus to be had, right? There's consumer and producer surplus there, right? So essentially, this chunk here is deadweight loss, and I'll highlight what I'm talking about. Let's do a different ink color. So your deadweight loss is going to be everything between your marginal cost and your demand curve. Okay, so there's people willing to pay for the good who can, like, if they were the producer, would be able to produce at a lower marginal cost than their willingness to pay. So for society, it makes sense to produce it, but for the monopolist, it does not, because the monopolist wants to maximize their profit by charging where marginal cost equals marginal revenue, not where marginal cost equals demand. Okay, so stop there, and I'll talk about that.